Welcome back to the Deep Dive. Today, we are looking at a document that, on the surface, seems pretty standard. It's a syllabus.
Right.
A syllabus for a computer science course, CS330, programming languages and compilers. It's for the spring 2026 semester at Skidmore College.
Yeah, and it sounds so dry when you say it like that, a syllabus.
Yeah.
But when you actually dig into the slide deck and the course policies, this is not just a schedule of exams. It's more like a manifesto on how humans are supposed to stay relevant in the age of AI.
That is exactly the vibe I got. You've got this incredible tension right from the very beginning. It's a course set in the near future, 2026, and the professor is teaching students how to build this really fundamental, bare metal software. But at the same time, he has to manage the fact that AI can now write most of that code for them.
Precisely. The whole course seems to be grappling with this one core question. In a world where machines can generate software, does anyone still need to understand how the plumbing actually works?
So our mission today is to unpack that. We're going to look at the, let's call it old school roots of the class, and then the new school AI policies, which are, some of the most detailed I have ever seen.
And the specific tool they built just to monitor how students are thinking, it's fascinating. But we should probably start with the architect of all this.
The instructor, Dave Reed.
Yeah.
I was looking at his bio, and he is just not your stereotypical CS academic.
Not at all. And I think that context is so crucial for understanding the whole course. He lists himself as a technologist and an educator, but then the word cloud he uses also has musician, an introvert.
I noticed that music connection. He has a bachelor's in music education before he even touched computer science.
That's a huge pivot.
It feels like one, but is it?
Well, it is and it isn't. Music and coding, they share a lot of DNA. They're both about patterns, syntax, structure. If you can read a complex score, you can probably trace a complex algorithm.
That's a good point.
But what I think really shapes this syllabus is his industry experience.
He spent, nearly 30 years in the corporate world?
Yeah. 13 years at GE, 15 years in consulting at a firm called Blue Slate. This is not someone who's spent his whole life in an academic lab.
He knows what happens when software breaks in the real world.
Exactly, in healthcare and finance. But he's also got this recent academic update that I found really interesting.
He's Ed D from Baylor.
Yeah, he just finished it in December 2023. And I think that's a great detail because it means he remembers what it feels like to be a student.
Right, the pressure, the deadlines.
The temptation to take shortcuts. He's not disconnected.
And speaking of not taking shortcuts, we have to talk about his winter break project. This is where the nerd cred just goes off the charts.
The PDP-10.
Yes. He has this section called A Brief Aside, My Interest in Historical Computing Platforms. And most people, they relax over winter break. Dave Reed built a kit to emulate a computer from the 1960s.
And not just any computer. The PDP-10 is legendary. It's the machine that was at the heart of the original AI labs at MIT and Stanford. It was the workhorse of the early ARPANET.
Okay, so for listeners who might not be computer historians, why does that matter so much?
The ARPANET was the precursor to what we now call the Internet. And Dave actually shares this slide. It's a logical map of the ARPANET from March 1977.
I saw that. It's this tiny, almost fragile-looking web that's just connecting a few universities.
Totally. And by building a PDP-10 emulator, he includes photos of him literally soldering resistors and plugging in chips. He's grounding the students in physical reality.
The photos are great. You see the circuit board on a piece of cardboard, the soldering iron. It's incredibly tactile.
It just sends this message, right? Everything we do on our shiny laptops or inside ChatGPT runs on physical hardware. It's about electrons moving through silicon. If you don't respect the hardware, you can't really understand the software.
So he establishes this baseline. Know your history. Then we get into the actual subject matter. Programming languages and compilers. I feel like we should define our terms here. What exactly is a compiler?
So think of a compiler as like the ultimate translator. Computers only understand binary ones and zeros.
Right.
Humans understand languages like C or Java or Python. A compiler is the software that takes the human-readable code and translates it into that machine-readable binary.
So it's the bridge.
It's the infrastructure of the bridge.
Yeah.
And the syllabus defines languages as human-made abstractions. That's a key phrase.
Human-made abstractions, so they're not like natural laws.
Right. Someone decided that a certain command should look a certain way. They made a choice. And the whole point of this course is to study the life cycle of those languages. How are they born? Why do they die? And the big project.
The one that keeps students up at night?
Oh, absolutely. They have to build one.
They have to build a compiler.
Yes. They aren't just writing code, they're writing the software that translates the code. It is a massive undertaking.
And to help them, he's using a textbook, Introduction to Compilers and Language Design by Douglas Thane.
Second edition. And significantly, it's a free download. Reed really emphasizes accessibility. He even quotes that old proverb, give a person a fish, feed them for a day.
Teach a person to fish, feed them for a lifetime.
Exactly. But he applies it to documentation. He says his goal isn't to get them to memorize syntax. He wants them to develop intuition and the skill to find useful documentation.
Which makes total sense. In the real world, you don't memorize the manual. You have to know how to look things up.
And you have to know what to look up. That's the intuition part. His whole methodology is really clear on the slides. Overview, then hands-on, simplify to the core, and then add complexity back in. He breaks the monster down.
Okay, so we've got the foundation. We've got soldering irons, history, compiler theory. But this is spring 2026. The syllabus has to address the elephant in the room.
The AI elephant.
It's huge. And in a lot of classes I've seen, the policy is basically, don't use it or we'll catch you. But this syllabus, it takes a completely different path.
It leans right into it. The syllabus explicitly says that large language models, LLMs, are just another programming language family.
That's a fascinating reframe. He's not treating AI as a cheating tool. He's treating it as a new syntax you have to learn.
But he's not just, letting them loose on the open web. This is where it gets really interesting. The class requires students to use a custom tool he built called the BitBuddy Assistant.
BitBuddy, I love the branding on that.
It's great, right? It's got a purple robot mascot, and the slogan is, your bite-sized CS sidekick.
So why build a custom tool? Why not just let them use ChatGPT or something?
Visibility. The syllabus says any use of an LLM for lab work must go through this front end. And this allows the professor to capture an accurate data set of LLM interactions germane to our class.
So he's spying on their prompts.
Spying is a bit harsh. Let's call it observational research. He wants to see the workflow. He doesn't just want the final answer. He wants to see the negotiation. How did you ask? What did the bot get wrong? How did you correct it?
That is brilliant. Because that back and forth, that is the skill of the future.
Exactly. And there's this little detail in the BitBuddy notes that I found hilarious and just so realistic. One slide notes, O3 licenses have not been purchased.
O3 licenses. That feels like such a specific 2026 problem to have.
It really grounds the whole scenario, doesn't it?
Yeah.
It implies that by 2026, we have these tiered models. You've got your standard GPT 5.2 or whatever, and then you have the high-end O3 reasoning models that cost serious money.
And the department budget didn't quite stretch that far.
Sorry, kids, you're stuck with the mid-tier bot. But you can see from the interface screenshots, it's still clearly capable. There are payload tests for haiku and pirate speak and hello world and C.
But the most valuable part of this whole policy, and this is something I think every single person listening should pay attention to, is how he categorizes the modes of using AI.
Yes. This framework is gold. He breaks it all down into 3 distinct modes of operation.
Okay, let's go through Mode 1.
Mode 1 is, I've got this.
Yeah.
No AI. 0. You rely on your brain, the textbook, the official documentation. This is pure human effort.
I imagine that's harder than it sounds for students who grew up with these tools.
Oh, it is. But it's so necessary for learning the basics. If you never struggle in Mode 1, you never build that mental model of how the code is supposed to work.
Okay, then there's Mode 2, Vibe coding.
Vibe coding. I love that he put that slang right in the syllabus.
It's a great term. What does it mean?
This is where you treat the LLM as a team member. You're bouncing ideas off it. You might ask it to explain a concept or suggest a structure, but, and this is the critical rule, you are collaborating. You modify the output. You have to attribute what is yours and what's the machine's.
Okay, and then Mode 3.
Mode 3 is you do it.
Total delegation.
The LLM generates everything. The human's only job is to refine the prompt.
Now, in a normal class, Mode 3 would just be called cheating. But here, it seems to be an option. With a catch.
A massive catch. You can choose your mode, but after you use BitBuddy, the system forces you to complete an LLM usage survey.
And what's on the survey?
It asks 3 things. What was the value of the output? How much of the submitted work is directly from the LLM? And the big one, how did you verify what the LLM gave you?
How did you verify? That's the kill shot.
It completely changes the responsibility. If you use Mode 3, you do it. And the code works great. But if that code is broken or inefficient or insecure, you are responsible. And if you didn't do the Mode 1 learning, if you don't understand the compiler theory, you won't have the skills to even know how to verify the output.
That circles back so perfectly to the course theme. You need the old school knowledge to police the new school cool.
Exactly. You can't fact check the robot if you don't know the facts yourself.
The course doesn't just treat AI as a tool to be managed, though. It treats it as a subject for some pretty intense debate.
Yeah.
The reading list for this class is, well, it's not exactly hype-friendly.
No, it's very skeptical. The professor's clearly trying to puncture the bubble.
Let's go through some of these titles. The first one that jumped out at me was, Is Gen AI Digital Cocaine?
Yeah, subtlety is not the goal there.
Yeah.
That article argues that AI coding assistants created dependency. The idea is that once you start using them, your own mental muscles start to atrophy.
You become addicted to the ease of it.
And you lose the ability to code sober, so to speak.
That's a terrifying analogy. But there's another one that's about security. Open source Project Curl is sick of users submitting AI slop vulnerabilities.
This is a real-world problem happening right now, and AI slop is such a visceral term. It refers to code that looks correct, it has the right shape, the right keywords, but logically, it is garbage.
The hallucination problem.
Right. And the article talks about how maintainers of major projects like curl are getting flooded with these bad reports, bad code patches, all generated by AI. It wastes human time. It clogs up the gears of open source.
So the students reading this and realizing, oh, if I just generate code and submit it, I'm part of the problem.
Exactly. They are learning that being a brain-dead coder, that's the other term from the readings, is actually harmful to the entire industry.
Yeah.
It's not just lazy, it's pollution.
There's another title here. GPT-5 is a mixed bag.
Which suggests that even in 2026, with the next generation of models, we still haven't achieved perfection. The developers in that piece note that while the models are great at reasoning, they still struggle with actual implementation in complex environments.
Not a magic wand.
Far from it. And my favorite is probably what actually happens when programmers use AI is hilarious.
I feel like we've all been there. You spend 20 minutes trying to get the AI to fix a bug.
And you realize it would have taken you 5 minutes to just write it yourself. And then there's the one titled, Writing Code Was Never the Bottleneck.
Which implies that the hard part isn't the typing.
The hard part is the thinking, the logic. AI speeds up the typing, sure, but it can't speed up the understanding.
And the students don't just read these articles passively.
No, they use a tool called Perusal. It's a collaborative reading platform. They have to highlight text, write comments in the margins, and actually debate each other inside the document itself.
So they're literally arguing about whether AI is digital cocaine, while using an AI tool to write their code for another assignment.
It creates this culture of critical usage. He's not banning the tool. He's teaching them to distrust it. Trust, but verify, but maybe mostly verify.
So let's talk about the logistics of the class. How does he actually enforce this culture? The syllabus mentions something called the 2-1 rule.
This is a neat little pedagogical trick. Every week, students have to write a journal entry about what they learned, but the rule is it must be a minimum of 2 paragraphs, and you have to include 1 quiz question.
A quiz question.
Yeah, you have to write a question that could be on a test.
That is so clever, because to write a good question, you have to understand the material better than if you just tried to answer one.
It forces metacognition. You have to think about your own thinking. What was the core concept here? How would I test someone on it? It shifts them from being passive consumers to active participants.
And speaking of active participants, there's a warning in the syllabus that gave me flashbacks to law school.
The cold calling.
I am free to call on you to answer questions and offer insights.
In a world where students can hide behind screens and behind BitBuddy, this is the professor saying, no, I need to talk to you. You have to be ready. You can't just zone out.
It really feels like he's trying to keep them awake.
Literally and metaphorically, he's trying to prevent that zombie state where you're just hitting the generate button and nodding along. He wants the human in the loop to be actually present.
So when you step back and look at this entire package, the PDP-10, the compiler project, BitBuddy, the digital cocaine debates, what is the big picture here? What is CS330 actually teaching?
I think it's teaching resilience. We are in such a weird moment in history. We have one foot in this bare metal past, soldering resistors, and we have the other foot in this generative future, prompting O3 or GPT-5.
And this course is arguing you can't survive the future without the past.
The syllabus actually has a mission statement. It says the goal is to expand a student's ability to create performant, easily maintained, and reliable software.
And to do that?
To do that, You have to understand your tools deeply. Whether that tool is a compiler that translates text to binary or a chatbot that translates a prompt to text, they are both just layers of abstraction.
And if you don't understand the layer, you are trapped by it.
Precisely. If you rely on the AI to do the thinking for you, you are not the engineer anymore. You're just a consumer. You've become the brain-dead coder that the readings warned you about.
It really does feel like this class is trying to train the last line of defense against all that AI slop.
Or maybe the first generation of true AI native engineers, people who know how to wield the weapon without shooting themselves in the foot.
And Dave Reed, with his soldering iron and his O3 licenses not purchased sign, seems to be threading that needle pretty well.
It just highlights that technology isn't magic. It costs money, it consumes power, it requires licenses, and, sometimes it just lies. The students leaving this class will hopefully see the machine for what it is, a tool, not a god.
So here is the takeaway for everyone listening, whether you're a coder or not. This syllabus really gives us a framework for our own work.
The 3 modes.
Exactly. The next time you open up ChatGPT or Gemini to get some work done, you should ask yourself, what mode am I in right now?
Am I in mode 1? I've got this. Am I using my own brain to build my own skills?
Am I in mode 2? Vibe coding. Am I collaborating, bouncing ideas around, but still keeping control?
Or have I slipped into mode 3? You do it. Am I just letting the machine drive?
And if you are in mode 3, do you know enough about your own compiler, the fundamental reality of your job, to know when the AI is lying to you?
Because if you don't verify, you're just generating slop.
A sobering thought to end on. Thanks for diving in with us.
Always a pleasure.